Hi, this is Patrick Henry, the CEO of GroGuru. I'm here today with Dr. David Sloane, who is a PhD agronomist and also the Chief Agronomist at GroGuru. We're going to talk today a little bit about GroGuru InSites, the SaaS platform, software as a service platform that GroGuru provides to the commercial farming industry, and a little bit about kind of how that works in conjunction with the GroGuru WUGS solution, the wireless underground system, which enables permanent installation and annual field crops, which is the vast majority of irrigated crops in the US and worldwide. And in fact, the vast majority of crops that are rain-fed that aren't using irrigation systems. So GroGuru is really all about water management, irrigation management. We help farmers make more money by increasing crop yield and more efficiently using water and other scarce resources in a more sustainable way. So with that, I'll introduce David, and he can give you a little bit about his background, and we'll just chat a little bit about what we're doing with GroGuru InSites, software as a service, as well as our overall platform implementation. David?
So, yeah, well, the first thing you'll notice about me is that I'm an Aussie, but I've been working with irrigated row crops for probably 30 years now. I have spent a lot of time in the US. I've been working here for the last probably 14, 15 years, and been with GroGuru for the last 3 years. And I'm a specialist in irrigation management and especially working with capacitance probes.
Thanks, David. So let's just get into it. So one of the things that we've been doing over the last several years, as you know, because you've been intimately involved in it, is developing an improved software as a service for irrigation management for farmers. I mean, one of the funny stories, you know, that you and I had when we were visiting with a customer down in the Texas Panhandle, and this is a more sophisticated irrigator, one of the much more sophisticated irrigators that we've ever run into. And I asked him how you manage irrigation, and he said, well, I have to look at 5 computer screens and have a yellow pad. And then we asked one of his neighbors the same thing and told him that story. And he just laughed and said, yeah, sometimes you need the yellow pad just to do the math. So clearly there's an opportunity for improved decision support systems for irrigation management. I mean, the market's come a long way since you got started in it. Can you tell us a little bit about kind of where we've been and where you think we're at and where we need to go?
Sure. Well, as I said, I've been doing this a long time, and farmers have always been frustrated when you bring them another tool because they go, great, this is awesome. I like the tool, but now there's another software to learn. And you know, I've got my software for my weather station. I've got my software for my soil moisture. I've got my software for my pivot control and all of that. Wouldn't it be nice if things just integrated? And so what we're doing is we're bringing together all of that data and actually leveraging it and using not just collecting information, but actually making the data talk to each other and make decisions which largely automate what farmers are trying to do with that yellow pad in their calculator. And so really InSites, GroGuru InSites, our online platform, is about not just bringing that data together and automating it, but it's about process control. It's about providing a roadmap on where they should be with their irrigation management, because there is a right amount of water to apply at the right time. So crops don't need access to the same amount of water for the whole of their life cycle. They start out as seed, and a corn crop goes to 10 or 12 feet tall. So clearly the moisture demand varies. And also there are times when you can stress crops and actually get a benefit, or maybe hold water back is a better word to describe that rather than stress them. But and then there are times when you can't afford to let them stress. So you have to keep the water up to them. And so it's what we like to call strategic irrigation management. It's knowing when to put that water on. And so if we can combine that with access to climate data and the irrigation data and give them a roadmap, then we can help them stay out in front of anything going wrong. So it's the process control part of it. So you can look at your entire operation and know that, yeah, I'm in a good space. I've got not just adequate moisture today, but I've got adequate moisture for tomorrow and the day after, or for the next week or two, or I don't, and therefore I've got to plan and irrigate, have a strategy, you know, to stay out in front of it, so you don't run out of water at critical times.
Yeah, one of the interesting things I've learned from you over the years is, and especially, an application to field crops, broadacre row crops, we call them, corn, soybeans, cotton, wheat, sorghum. So these are crops that have to be seeded annually, and then it has a destructive harvest. So you replant them every year. And part of it is not only irrigating the crop, it's growing a robust root zone. And in order to feed the plant, in order to have the plant drink, you need to have that robust root zone. So managing the root zone during that growth period becomes critically important, because if you don't have that robust root zone, as you've said, it's kind of like having a shallow straw in a deep glass of water. You can only get access to a certain amount. So I think that's really been fascinating, kind of learning that from you. And by having soil moisture monitoring, in addition to these other tools, you can do that a lot more effectively. So let's talk a little bit about kind of that combination of different things. A lot of the pieces that we're pulling together in GroGuru InSites is weather forecast, crop models, the as applied information from the irrigation system. And obviously GroGuru can't do all of those things ourselves. So we've built, a network of strategic partnerships. One of the most significant that we recently announced was a partnership with Valley Irrigation, also known as Valmont. These guys are the market share leaders in center pivot irrigation systems. I don't know, they have 40 or 50% market share. So they are the dominant player in that market. And we now are able to access through what we call a application program interface, an API, data from their center pivots or wherever they have their communication systems connected. They have 128,000 connected devices deployed worldwide. And this includes center pivot irrigation systems, soil moisture monitoring sites, weather stations, rain gauges. Obviously, this is a big deal for us. Can you talk a little bit about kind of the catalyst for going forward with that, and what that has the potential to provide for farmers in terms of integrated dashboard?
Yeah, well, first I'll say that we're pretty honored to be actually selected as an API partner, because they're not working with everyone. So they clearly see what we can bring with both our irrigation agronomy expertise, but also our wireless underground solution, our WUGS, to bring data all season. Well, not all season, but permanently, so all year, 365 days a year. That data is really crucial as well, which we can talk about further. But no, this deal with Valley is huge, because a lot of our customers are already using that system. So the push, I guess, came from the market to say, hey, we really like what GroGuru is doing with us, and we really like their technology and InSites software. But we'd also like to get our Valley-enabled systems, our AgSense systems, to be able to send data to GroGuru, so we can bring it together on InSites. So it's been very much a market pull situation, and I'm glad that Valley has come to the party. And as I said, we're very honored to be partnered with them, because they do select their partners wisely. And so far, the integration is working well, and so we've got happy customers. And so it's a new relationship, but it's working well, and we're excited.
Yeah, it's interesting. One of our customers, CSS Farms, the head of agronomy over there, had mentioned that having things on a single dashboard, including the as applied data from the irrigation system, is really critical. I think that one of the things that we noticed in the marketplace is there's a large installed base, relatively large, thousands of units of soil moisture probes. Predominantly our two partners, Sentek and AquaCheck. There are some other ones out there as well, of course, but we support both of those systems, again, through a software relationship. AquaCheck we use exclusively right now in our wireless underground system, which we'll talk about in a bit. And Sentek, with their drill and drop probe, they've got a significant amount of annual install and removal business, which, by the way, is important in a lot of cases. So one of the things that I'm noticing is that the customers are really, because of the 5 screens and a yellow pad, they really like not only having the integration of that capability onto a single screen, but also uniformity across their different platforms. So, one of the things we're providing is a hardware agnostic solution, and we can kind of abstract from that so that no matter which site they're looking at, whether it's using AgSense telemetry or Zensio telemetry or GroGuru telemetry, they get kind of a uniform look and feel, which obviously is a huge benefit. What's your experience been talking to farmers about that?
Well, I was just going to mention that one of the things that CSS really were attracted to GroGuru with was our ability to reach across different platforms. They're a large company. They're operating in, I'm not sure how many states, but 10 or 14 states. And, we've got we're already working in about 8 of those states. And they've got legacy equipment. And so they wanted to be able to use that legacy equipment on a single platform. And there wasn't a way of doing that before we came along. Plus, they really like all of the, not just integrating the data from different systems, but also bringing in the crop models and the weather data and that sort of thing as well. So it's what we designed it to do, and it's working well, and obviously getting good customer appreciation in that regard. And as far as the agnostic systems go, we also are able to bring in data from Sentek as well. So there's got a lot of customers that have been using different combinations of Sentek equipment, either with their own, like the Sentek provided telemetry, or with third-party telemetry. And unfortunately, they've got different kinds of probes and they're not really compatible. So Sentek themselves were finding it hard to bring data in from third-party systems. So we're able to provide that to their customers as well, that ability to offer a single dashboard for different types of hardware and different types of equipment. So yeah, that agnostic ability is really powerful.
Yeah, I mean, one of the things we did, I mean, we obviously initially started with our hardware-enabled SaaS product, and we still have hardware-enabled SaaS. It's just now that we're using some partners for some of the third-party stuff that's already deployed and in the field. It lowers the cost of entry to switch to GroGuru InSites versus having to buy all new, and maybe they only bought this equipment maybe a year or two ago, so it's still got some decent useful life associated with it. But we've really seen our revenue and our SaaS business really accelerate over the last 6 months based on this. So this has been a way for GroGuru to expand our footprint rapidly, even as we continue to deploy the GroGuru wireless underground system in a lot of places as well. That business is continuing to grow as well, as you know. So let's switch gears a little bit and talk about our partnership with DTN. For those of you who don't know, DTN is a leader in providing weather forecasts, especially to farmers, and then also crop models, which basically the equivalent of what David's talked to me about historically is that the soil moisture probe, think about it like a gas gauge for the crop. The crop model is more like a trip meter. So with a 10-day forecast, so you basically able to look at that. So talk to me a little bit about that and kind of what we're doing there and why that's important to farmers.
So yeah, if you take the gas gauge and trip computer analogy, I mean, everyone likes to know how much gas have I got? Have I got half a tank, or I've got 3/4 of a tank? But what you really want to know is how many miles to empty, right? I want to know, when do I need to gas up? Do I have 50 miles range, or do I have 350 miles range? Because I'm going to make different decisions and based on that. So having the crop models actually enables us to look into the future, and we can look 9 or 10 days out and know what the crop is forecast to use over that time. So if we know how much moisture we have in the soil and how much moisture that we think we could have access to, and then align that with how much water the crop is forecast to use, we can then predict when we need to irrigate again. And so it's also important when some of these people may take, in certain parts of the country, especially with row crops. So if you take the Western Corn Belt, which is Western Nebraska, Southwest Kansas, Northern Texas, it's a very dry environment. Northwest of Northern Texas, it's kind of a desert, and we're growing corn there. And so you have to irrigate very, very slowly, and it may take 6, 8, 10 days to make one irrigation. And so if you can look 9 or 10 days into the future and know how much water the crop is likely to use, and you can compare that with how long it takes you to irrigate, you can actually do a couple of things. You can see how far behind am I going to get, because most of the people in those areas can't actually put enough water on to keep up with the crop. So you're basically, it's called deficit irrigation, but you're drying the soil out slowly, and hopefully it's slowly. And if the conditions are such that it's going to be too hot and too windy, you may not have enough soil moisture, so you've got to make a different decision with the way you irrigate. But as far as the models go, we can potentially change the way we irrigate even within that cycle, and so start to apply or counteract the weather. So if you know what the weather is likely to do over the next 8 days, and it takes you that long to irrigate, then maybe you can start to apply water differently even within that cycle, speed up, slow down, that sort of thing. So it's pretty exciting stuff when we can increase the efficiency even more than what people are doing just by running around at a set speed.
Yeah, I mean, what's interesting to me, and I kind of look at the analogy of the autonomous tractors. I mean, there's so much technology in these tractors and combines and everything now that, I mean, they basically are, we talk about driverless vehicles. These are basically driverless vehicles already. But the farmer still sits in the cabin. You know, they still want to have control. Very few farmers, because so much is at stake, they're not going to go fully automated. But I think what we're trying to do with GroGuru InSites is provide that easy button, which is really the precursor for irrigation automation. But maybe it's just like the cruise control on a car, but you're still in the driver's seat and still managing it. So I just think it's super exciting what we're doing there. So any kind of final comments on InSites, and then we'll switch gears a little bit and talk about WUGS.
Sure. Well, just with that cruise control aspect, people may not know, but a lot of these farmers are dealing with 30, 40, 50, or even 100 pivots. And so while the technology is there to make the decisions, they just don't have the time to really sit down and study everything. So, I mean, everyone wants easy, right? But sometimes easy is a necessity, just because, you just don't have the time or the bandwidth to make all the individual decisions. So where we can automate things, it's going to really pay huge dividends.
Yeah, just to put that into perspective for our listening audience, each pivot, a small pivot, a 7-span pivot, what they call a 1/4 mile pivot, that's 120 acres under the circle. The big ones, the 1/2 mile pivots, that's 480 acres under the circle. So these are some big commercial farmers, for the most part, multi-generational family farmers, but it's a lot to manage, and having that scalability by a very effective decision support tool that has abstraction. One of the things we do is green, yellow, red, and give people kind of that exception reporting that's been done in the enterprise for years now. It really hasn't been done effectively so far in the farming industry, and the farmers really appreciate it. And even agronomic consultants, these are like guys like David Sloane, that basically are helping farmers manage all this stuff. They even find it very valuable because it's more scalable. Maybe historically they could only manage, 30 to 50 sites. Maybe they can manage 10 times that many now with a very good tool. So, and some of those guys are our dealers, our channel partners. So we've been getting great feedback around that. And it's an exciting time for GroGuru as it relates to that. So let's talk a little bit about kind of the combination of GroGuru InSites and GroGuru WUGS, the wireless underground system, as it applies to field crops. I mean, obviously there's some other important stuff we may have to do another video to talk about that. But let's talk specifically about field crops and the advantages of that very powerful combo of GroGuru InSites and GroGuru WUGS.
So you sort of touched on it earlier, but one of the biggest things, soil moisture probes are not new. They've been in the industry for 20 years or more. And the reason for that, and increasing too, the reason for that is because they work. You need to measure it to manage it. And so people have learned really how to be much more effective irrigators. The trouble is that the scalability factor of having to go and install. So what you do is you plant the crop, you let it emerge. And so you have a plant stand, and then you need somebody to go and install the sensor. And then at the end of the season, you've got to pull it out again. And so you've got to get it out of the way of machinery. So you have to plant the crop, or the probe can't be there. And then when you harvest it, it shouldn't be there either. So there's just a lot of work around that. So number one, by having a probe
that's the competitive alternatives require that kind of
correct.
Very
That's
arduous, painful, non-scalable process.
That's what is the current state of the art in the industry. And the reason we're disruptive is because we're putting the probe in and we're leaving it there. And so not only is it already in, but I've also got 6 months that when the crop's not in the ground that I could be installing. And so rather than having to do it all in a rush, because if you think about, corn or any crop, there's a planting window. And so you've got to get that crop in as quickly as you can in that planting window. So you take 8 million acres of irrigated corn in Nebraska, and it's all planted in 3 weeks. And so trying to get around and install equipment in that time, in a really narrow time frame is damn near impossible. So there's a physical limit to how much you can put out. But if you're putting it in and you're leaving it in there for years and years, and you have now, instead of 3 or 4 week installation window, you've got a 6 month installation window. The scalability is massive. But let's put that aside. I mean, that just is nice for the industry in general.
Before you go to the next benefit, let's just kind of hit that pretty hard.
Okay.
So if you look at, a 4 week window after crop emergence, you got to get them in the ground. If it rains, 4 weeks is 3 weeks. And then you have to go through a few wetting cycles before you can even use them. And then you got to take them out of the ground, get a 4 week window to get them out of the ground before harvest. So you really have a subset of the growing season that you have this great information, but it's very limited compared to what you provide with a permanent install. Because I think that's where you're going, but I think I just want to kind of hit that pretty hard. So if you look at a 6 month install window and you only have to do it once every 5 years, that's a 30x improvement in install scalability. And it also, every time you roll a truck to do an install, it's like $350. So the total cost of ownership also comes way down with the permitted install. So it's a huge deal. And this is why we're being so successful in converting competitive alternatives, especially in field crops, where the competitors cable from the sensors in the ground to the above ground communications. We don't have that. So it's a huge deal, but you're going into kind of the permanent install and basically the amount of time that we're in there and the value of that.
Sure. So you touched on the fact that you need wetting cycles and things to bed the probe in. So I was going to say, hey, let's put aside the scalability because that's kind of a no-brainer, but you just captured that by saying 30x increase in scalability. Awesome. But when it comes to using the data, which is obviously as an irrigation agronomist, that's what I get excited about. The data is just so much better. Why? Because, well, there's a number of reasons. But at the beginning of the season, I need to know how wet is wet. And so you need to get it wet. And if the install's late and the crop's already using water, you may never get it wet. So you may not know exactly how much water the soil can hold. And therefore, all your assumptions are kind of flawed anyway, straight out of the gate. But if I've had this probe in over the winter and coming into the spring when generally it rains and then also early irrigation, I'm going to know how wet is wet. There is a physical bedding in that the probe goes through. And so you just need to get a couple of wetting cycles to also help it gel with the soil. And so if I've done that prior to planting the crop, then straight out of the gate, I've got better probe installation, and I've also got better data in terms of I know where my full point is, which is the way all users of these probes have to get dialed in. It's kind of like hitting tear on a balance. You need to get that baseline, and so already I'm ahead. But then you throw into that, well, what happened over the winter? If I've got my probe installed and then I get some rainfall over the winter or I get snow melt, let's say I've come out of the previous crop. So now I've gone through a cropping cycle and I go into the winter. So if I'm in Texas, in Amarillo or somewhere like that, or Southwest Kansas, Garden City, I'm going to assume that the crop's taken all the moisture out of the soil because let's face it, why would I not do that? It would make sense rather than having to irrigate. So if the soil's dry, well, I'm assuming that I'm hoping that I get enough winter moisture to fill the soil back up. But in that part of the world, you don't always get that. In fact, more often than not, you need to supplement Mother Nature. And so knowing just how much winter.
And this is before you put crop in the ground. This
is coming, So this is, so let's say I've come out of one season, I'm in the winter time, and I'm I'm starting out dry after my first crop. It's rained, but how much does that wet the ground up? I need to know that because I've got to make sure that I'm full coming into the next season, because in that environment, I mentioned before, deficit irrigating. It means that I need to use the stored soil moisture. It's part of my secret sauce of growing a high yielding crop. And so I got to refill my piggy bank, or else I'm not going to get a good crop. I need to refill the soil. So being able to measure it, and then assuming that Mother Nature doesn't help you out with snow melt or rainfall, I then need to pre-irrigate. And in that environment, if you go in what's called the high or the North Plains of Texas, just north of Amarillo, a lot of there's probably 1 million acres of corn grown in that region, and they need to generally pre-irrigate every year. And they may put on 2 inches of irrigation water, they may put on 6. And 6 inches out of a 24-inch allocation, that's a big percentage. That's a quarter of my irrigation budget put on even before I put seed in the ground. And traditionally, I wouldn't have been monitoring that. In fact, I would have been flying completely blind.
With the competitive alternatives, they're not even in the ground during that period of time. And that obviously is a huge deal. It's really interesting because when we were selling in year one, so when we launched the wireless underground system in 2019, a big reason why farmers converted is because of the scalability factor, the permanent install, those types of things. As we started talking to them at the beginning of season 2, and they started looking at the data and also having soil moisture probes in the soil before they planted crop, they're like, this is even more important, is being able to manage kind of not only the beginning of the season, but before the beginning of the season. Because as you mentioned before, if you don't measure it, you can't manage it. So even when they were doing pre-irrigation before, they were guessing. So now they're actually able to do pre-irrigation much more effectively. And then at the tail end of the season, after you already have the soil moisture probes removed, sometimes 1 or 2 wetting cycles can mean the difference between a banner crop and an average crop. Can you talk a little bit about kind of those things a little bit?
So absolutely. The best, I guess, just going back to the competitive alternatives, probably the most accurate decision you'd ever make is when to finish, because you've got a whole season of data, and now you've got that probe bedded in, and so you can actually, probably part of the value proposition was just knowing when to finish. Can I save an irrigation, or do I need to put that to keep irrigating to keep my yield up? And so, that's where a lot of people have had a lot of success. But sometimes what would happen is you go into an area, especially if you're using contractors, and they'd be in an area and they say, right, it's time to, 90% of the crops have had their final irrigation put on. We'll go and extract all the probes. But maybe there's a few fields that got planted late, and they get their probes pulled out before you've put the final irrigation on. And I got to tell you that farmers get pretty frustrated with that, because there goes the value proposition. But that happens, and it happens more than you'd think. So plus the data is shown once we've left the probes in that there's a lot of learning that happens. People pull them out because of convenience, but if you can leave it in there and start to collect that data. Now, if we pull the probe out, the telemetry away, just so you can run the combine through, we're still logging data. We've got 6 weeks of logging capability, so we can get an unbroken data set that goes all the way through the harvest period. Even if things are disconnected in the data flow for a month, we're still going to get all that data back. So it's not lost, and we're learning a lot about how much our water gets pulled late in the season from different crops, and that was something that nobody ever knew before. So it's really valuable stuff. And similarly,
it's interesting because and this deals like with the combination of the David Sloane expertise and one of our co-founders, Farouk Anjem. He's also a PhD in electrical engineering and really an expert in wireless systems and machine learning. And kind of the combination of the crop science that Dave brings to the table, and then Farouk bringing the machine learning, there's a lot. Think about it like this. So if I took an x-ray of your leg and just handed to you and told you, interpret this, obviously you're not a radiologist, so there's going to be a problem. So think about David as being the radiologist for, irrigation agronomy. And what we do is we're trying to turn data, well, not only trying, but we are doing it, turning data and information into insights. And part of that is the machine learning component that, a David Sloane can work with a Farouk Anjem and be able to, determine by the signatures of the graphs, root growth, root depth, soil characterization types, a lot of information. And as Farouk says, when you leave the soil moisture probe installed in the same place over years, you have what's called clean data. And clean data is essential to apply machine learning algorithms effectively. So this is all about artificial intelligence. This is about using the capabilities that we have from human knowledge, translate that into machine knowledge, and it's something that it's just not scalable otherwise. This is another element of scalability. How many David Sloanes would you need to interpret, 10,000 sites? It's just not possible. So having that, turning data into information into insights through artificial intelligence becomes another key part of what we're doing. Can you touch on that just a little bit, Dave, and then we'll switch gears again?
Well, first off, I've got to give Farouk a lot of credit. He's brilliant. And he's really, really good at, we'll sit down together, and he's really good at picking up these signatures. So we'll sit down and he'll say, hey, you as the irrigation agronomist, what are you looking for? What is it that's the trigger point that's saying, okay, I need to irrigate now, or I don't need to irrigate now, or what is, how deep are the roots, or, all these different things that I guess I've just learned over the last 30 years, and you can't teach experience, but you kind of can when it's machine learning. You just throw enough data at the model, and the model gets experienced and it learns. And so being able to pick these signatures, once you explain what the signatures are all about and what we're looking for, Farouk's been very good at turning those into algorithms that we're starting to be able to pass through lots and lots of data. And so, like anything, the more data you get, the better at it you'll be. But also by having this unbroken data set, so for example, at the end of the season, instead of having the probe pulled out and the data stop, we've now got all that data so we can see just how dry, we know how wet's wet, but we also want to know how dry is dry, and just what a corn crop can do in certain different soil types and certain different regions, things like that, so that we can start to take that forward and say, okay, well, if this is what we've watched corn do, then this is what we can expect corn to do next year given the same circumstances. And also, maybe we need to switch it up a little bit. If we can pick areas for opportunities to improve things, then obviously we'll build those in as well.
Yeah, so we're running short on time, so I'm just going to wrap it up with one kind of key summary, but this has really been great. And I think we'll have to do another one of these to kind of cover a little bit more ground, but I think we've covered some key things around GroGuru InSites, creating an easy button for farmers, a better decision support tool that's more scalable. You combine that with the scalability and additional information and insights available from the GroGuru Wireless Underground System, the WUGS, with a permanent install. We now have, double, triple the scalability in terms of decision support, install time, install frequency, all of those kinds of things. But I think that one of the key things to not lose sight of the big picture is that by using, strategic irrigation management, as David calls it, farmers are not only able to save millions of gallons of water, they are also able to use that water in a much more efficient way. And what do I mean by that? We on average get a 10 to 20% increase in crop yield, while at the same time saving 10 to 20% on input costs, including labor, fertilizer, water, all of those things. So it's a big deal, and it's not only about water savings, it's about water efficiency. And if we're ever going to meet the global goals of increasing the amount of crop by 70% by 2050, while at the same time we're already using 70% of the world's fresh water supply for irrigation, agriculture irrigation, obviously the math doesn't work. So tools like what GroGuru is doing are essential to kind of reach those goals. So any kind of final comments here, Dave? Try to keep it to like a minute or two.
Sure. Well, I was just going to also say that with the WUGS, we're not just talking about irrigated agriculture here. We're talking about rain-fed agriculture, because traditionally the whole install, remove, scalability thing just made it too expensive to use this kind of technology in rain-fed agriculture, and also not having being able to join up one year to the next. So that continuity is really good for now.
So let me just ask a question about that. So if you can't control the weather, why would you install soil moisture probes in purely rain-fed crops where there's no irrigation? Can you explain that?
So that you can see exactly what the season is setting itself up for. And so there are two parts of rain-fed agriculture. There's those where you get too much spring rain. Well, they've got tile drains. So we're actually using wireless underground system like the
so tile drains are like French drains for a farming field, correct?
Yes. And
okay.
So those farmers are actually trying to take water out of the soil early, but usually they're not managing that, so they take too much out. And so you're losing opportunity. Plus, you're taking too much out, which is also carrying away a lot of nitrogen fertilizer. So it gets into the groundwater, it gets into rivers, it causes algal blooms. That's an environmental problem that we can really help solve. And so there's that side of rain-fed agriculture where you're trying to manage too much water by managing the water table. And then there's the rain-fed agriculture where do I have enough soil moisture to plant a crop? And that's when I'm making a decision on my input. So should I maybe back off my cost because the moisture is not in the ground? Maybe I shouldn't put as much seed and as much fertilizer, and just, yes, I'm not going to expect as high a yield, so I'm just not going to spend as much. And
so we probably need to have a follow-up discussion around that. So, but basically in a nutshell, even in rain-fed crops, which is like 5x the size in terms of acreage as the irrigated acreage. So massive market opportunity. GroGuru has been in trials for a couple of years, and we're seeing some good results around the use of pattern tile drains to kind of help flood mitigation, better manage water in the soil, all of those kinds of things. But it's a combination of, it's still, there's a potential yield improvement, but there's also a potential cost savings in terms of variable costs like application of fertilizer and things like that. Also, as you mentioned, yield prediction. So knowing how much you're going to get is a big deal as well, because that's a big cost and labor planning tool, correct?
Yeah, and we can also ground truth all the satellite data. So there's a lot of things that satellites are great at doing in terms of looking across the landscape and comparing, trying to look at vigor and all of those sorts of things. But if you can have eyes under the soil, which is where all the magic happens as far as growing a crop, the water and nutrients sort of get taken up where you can't see them. And so if you can see inside what's going on, you can ground truth all the satellite type data as well. So it's very powerful, especially when it's in there permanently. And so we're getting data from all year.
So a better way to say it maybe then is, instead of strategic irrigation management, it's really strategic water management.
Correct.
For commercial farmers. And in both cases, and even the intermediate case where you're using supplemental irrigation, we can help farmers increase crop yield, make more money, and more efficiently use water in a more sustainable way. So Absolutely. With that, until next time, thank you so much, David. This has been fantastic as always. Really appreciate your insights on kind of what goes on when you're actually managing the crop. And hopefully you folks will find that valuable. If you have any questions or comments, leave it in the comments section below. And we're excited to do another one of these again in the not too distant future. So thanks a lot. Take care.
Okay. Very good.